So in this video, I am going to explain this question which I recently asked in Codeforces around 897 dated for division 2. So first let us understand the problem statement. This is a problem C and it is an interactive problem. So so it is an interactive problem. So let me first tell you what does the problem said. So what problem said that we will be given a set, or rather we can say we will be given an array of n size. First of all, and there are two players Alice and Bob. And in one move, what Alice can do, Alice can add any number x in my set such that that number is not present in that set. For example, let it number be x, so I can add x in the set only when x is not present in the set. So in the second move is of Bob. So in second move, what Bob can do, Bob can remove any number from the set, which means Bob can remove any number from the set such that the number which Bob is removing must be less than the last added number which Elias has added. For example, last number which Elias added would be x, so the Bob can only remove a number y such that y is smaller than x. So what problem is that we have to what problem is that both the players want something from the array, and that is max. So how is max defined? Max is the function such that it is the smallest number which is not containing in the set. So now what problem is that our player Alice want to maximize the set, where it is written here. Alice aims to maximize the result while Bob's aim to minimize the result. So this is the whole problem. So how is interaction played? So first interaction is that we will be given an integer n and we have to take an integer inputs. So we are playing as a Bob, which means computer will be playing as a Bob. So which means we have to tell which number Li should add, or rather which means which number we should add in the set such that our overall result should maximize, which means our target is to maximize the result because we are playing as allies and allies want to maximize the result. Here it is written, let R be the result if the both players optimally. So we are playing as allies, so we want to always so we want the answer which should be at least R. R should be any number. So this is the whole problem intuition. So which means we are playing as allies and we have to give them input, and for that input we have to take a input also, which which the number Bob will be taking out from the set. And when the game over, there is one more condition. Game will be over. Game will be over when at any point, by which means at any point Bob cannot make a move, which means Bob cannot remove any number from the set. At that point, our game will be over. So this is the whole problem. So let me understand the problem intuitions. So let there be a set like 1, 2, 3, 4, and I'm taking this example only, and 5 and 7. So we are playing as allies. We are playing like as allies. So what should minimum number we should add in the set so that max is maximized? Here max is MEX, this max. So which number we should add such that R this max, which means R this max is maximized. So we should add a number, we should add that number which is the smallest number at not present in the set. Of course that is the only number we can add, because if I add any number, for example in this set we can see the smallest positive number, the smallest whole number which is not in the set is 0. But if I add any number rather than 0, then for example let me add 6 here, because 6 is also not present here. So then max is also 0, which means we are not maximizing the max, which means we are not maximizing the max, and we have to maximize the MEX, this max. So first of all we should add that number in the set which is the smallest number and not present in our set. So for example in this case it would be 0. So what are the number that allies can remove are uh, what number allies are removed, that you can even see allies cannot remove any another number from this array, because 0 is the minimum number, and the any number, and there is no other number which is smaller than 0 in this set. So max of this array would be 4, and which is the largest number which we can attain. So it is a small example. So let me take another example. So for example, an array is containing 0 initially, and this is the whole problem. So what number we should add now such that our this max is maximized? So what is the minimum number which is not present in this set? So it is 4. So I will add here 4. So now what is the max? Max is 6, which is maximized. But now my Bob can also make a turn. So let the number which Bob can remove is, for example, 0. For example, let it be 0. If Bob remove number 0, which means it remove a number 0, then what number we should add so that our so that our max is maximized? So the number which Bob has removed, this is the number which is removed by Bob, and this is the number which is added by Elias. So which number Elias should add in the set such that our max is maximized? It is clear. The number which Bob is removing, we can simply add that number again in the set, of course. So if our Elias again added 0 in the set, so but this number is added by Elias. So in the next move, Bob cannot make any more turn, and R max is maximized, which is, you can see, 6, which is a maximized answer. So but there is a case. If Bob doesn't remove 0, for example, if Bob doesn't remove 0, so let Bob remove any number like here you can see, let Bob remove this number, and now what is the max? But now my allies can make a turn. So which number allies should add in the array such that our max is maximized? So the number which Bob has removed, we can again add that number also. So this number is added by allies, so we can add that number also. So Bob can make but now Bob can make another more turn. So for example, now in this one, let Bob remove this number. So we will add again 1, because then our max will be maximized, which will be remaining 6. So there is another more turn which Bob can turn. So in this number, Bob removes 0. So if Bob removes 0, so what number we should add? If Bob remains 0, we can add a number 0 again. So here you can see, by adding 0, Bob cannot make any more turn, because there is a no number which is smaller than 0 in the set. So in this case, our max is maximized, which is always 6. So this is the answer. So which means, what is the problem intuition? Problem intuition is that, first of all, I will add that number which is the smallest, which is the max of all the number. First of all, I will add that number which is max of my current array. Then after adding max of my current array, what I was doing here, you can see, after adding max of all the set, what I was doing here, I was only adding that number again and again which Bob has removed, which means which Bob's are removed, which means the number which Bob will remove in next move, Elias will again add that number only, and this will turn like when this will stop when my least possible number is 0, because if Elias add number 0, then the next turn Bob has to remove a number which is smaller than 0, but there will be no number which will be smaller than 0, which means our answer is concluded, and our max will be that number which is the second max of my answer, because first max is my 4, then second max would be 6. So the question has not asked us for the answer, but only asked us for the Elias moves, optimal Elias moves. So if I show you the code, so you can see, first I am taking the input. So by taking by this loop, I'm calculating the max of my current input array. So first of all I will add the current max in my array. Then what I will do, I will simply take the Bob's number. So if any position Bob is not willing to make any move, then I will simply break, or else Elias will add that number only in the array. So this is the pretty much solution of it. So if you like the video, please don't forget to subscribe my channel. Until then, stay tuned for the next one. Thank you.